So let us discuss this example of metric. So they have defined D in this way. Okay, it is looking little bit complicated, but don't worry, actually it is very simple. And they have given set is X. X means set of, they have mentioned, I think, set of all real sequences. Okay, sequences 1 by n or 2 raised to n, right, or constant sequence. Such type of sequences are there in X, and D is defined in this way, and we have to prove that D is a metric on X. That means it should satisfy 4 conditions, right? First condition, it should be greater than or equal to 0. Second condition, it is equal to 0 if and only if X is equal to Y. Third condition is D of xy is equal to D of y symmetry, and the last condition, you know that it is triangle inequality. So let us start to do. So see, I will go for a first condition. For I am taking 2 elements, x is equal to xn. It's a sequence, so that's why it will look like this. So that means x1, x2, and so on, xn, and so on. Infinite terms are there, x and y is equal to sequence yn. That means y1, y2, and so on, yn, and so on. Many elements are there. Okay, clearly I can write one thing, that is mod xi minus yi is greater than or equal to, xi means what, any arbitrary xn, just like a x1, x2, such thing we have xi, and here yi. So if you subtract, mod is there, so that's why it is greater than or equal to 0, and this is true for all I, right? What will happen if I add 1 here? So 1 plus mod xi minus yi. If you add 1, you will have strictly greater than 0. Right? If you add 1, you will have strictly greater than 0, since it will be more than 0. No? Since if you add 1 here. And this is again true for all I belongs to set of natural number. After that, what will I do? I will multiply it by 2 raised to I. 2 raised to I means 2 raised to 5, 2 raised to 6, 2 raised to 7, like that. So if I multiply, what will happen? See, it's a positive number, it's a positive number, and 2 raised to I is also a positive number. This bracket is positive. 2 raised to I is also positive. If you take product, again you will have positive number. See, if you have any positive number and if you take its reciprocal, again you will have positive number. For example, 5 is positive. What is its reciprocal? 1 by 5. That is also positive. So therefore, if you take its reciprocal, 1 upon 2 raised to I 1 plus mod xi minus yi, that is also greater than 0. Okay, I will just remove this one. Okay, see, this is greater than 0, positive. This is non-negative, that means greater than or equal to 0. So if you take their ratio, then also it is non-negative. That means suppose a is greater than or equal to 0, b is greater than 0, then a by b, that is also greater than or equal to 0. So this is the funda we have. So therefore I can write, if you take their ratio, so therefore we can write mod xi minus yi divided by, okay, I will divide this one by this one. That means I am taking a product here. So that means 2 raised to I and 1 plus mod xi minus yi. This is also greater than or equal to 0, and this is true for all I. I should mention everywhere. I belongs to set of, for all I belongs to set of natural numbers. This is also true for all I belongs to set of natural numbers. So that means each of them is greater than or equal to 0. So that's why if you take summation, if you take their summation, then also it is greater than or equal to 0. So yeah, I am simply taking summation here. See what will I am writing simply. So 2 raised to I 1 plus mod xi minus yi. So this is also greater than or equal to 0. Have you seen it anywhere? Yes, this is definition of D. So therefore this implies D of x comma y. This is also greater than or equal to 0, and this is true for all x, y belongs to capital X. So therefore we can say our D satisfies its first condition, right? Okay, make a screenshot of it, and after that we will go for second condition. You remember the second condition, D of xy is equal to 0 if and only if x is equal to y. So let us start second condition. Okay, second condition, we consider D of xy is equal to 0, and finally what we have to prove? X is equal to y. if and only if it has only one definition, so we can directly write. So d of xy, what is its value? I will put it here. So summation I running from 1 to infinity, right? Mod xi minus yi divided by 2 raised to I 1 plus mod xi minus yi is equal to 0. Okay? See, none of them is negative. So mod is here, mod is here. There is no any chance of any negative number getting. So, but the sum is 0. So that means each of them should be 0. Then only their sum will be 0, right? So therefore each of them, okay, each term mod xi minus yi divided by 2 raised to I 1 plus mod xi minus yi is equal to 0, and this is true for all I belongs to set of natural number. Each of them is 0. What will I do? We have a denominator. Now I will shift it there. So if I shift it there, here is a division. If you shift it there, there will be a multiplication. But 0 is there. So 0 into anything, we will have 0. So that's why we can write this is nothing but mod xi minus yi is equal to 0 for all I belongs to set of natural numbers. Since 0 into anything, 0. Here we are getting mod 0. Mod 0, that means the number should be 0, which is lies inside a mod. It should be 0, then only we have mod 0. So therefore we can write xi minus yi is equal to 0 for all I belongs to set of natural number, right? Since xi minus y is 0, then only you will have mod 0. Can you guess the next step? Obviously, I will shift y on that side. So therefore, xi is equal to yi for all I belongs to set of natural number. So that means each of them are equal. So therefore, this is nothing but x1, x2 and so on, xn is same as y1, y2 and so on, yn and so on. Getting? Since each of them are, if you equate, equal. This is nothing but our x and that is nothing but our y. So we started with d of xy is equal to 0 and we are getting x is equal to y. So in this way we proved second property also. Okay, we will go for a third property, but before that make a screenshot of this one. Okay, so for third property we require two elements. So I am taking for x is equal to xn and y is equal to yn belongs to x. So two elements I have taken. You remember the third property, d of xy is equal to d of y. So we call it a symmetry. Okay, so let us start to do. So see, I will consider d of xy. What is d of xy? D of xy has a huge definition, right? This definition. So I will simply copy and paste. Summation I running from 1 to infinity, right? Mod xi minus yi upon 2 raised to I 1 plus mod xi minus yi. Okay, do you know one important thing of mod? That is mod a minus b is same as mod b minus a. So that's why mod xi minus y we can write it by mod y minus xi, correct? So this is equal to summation I running from 1 to infinity mod yi minus xi. Okay, in denominator also I can do the same thing, 2 raised to I 1 plus mod yi minus xi. Okay, so this is nothing but at a x and y we have, and here y and xi we have. So this is nothing but d of yx. So we started with d of xy and we got d of yx, and this is true for all xy belongs to capital X. So therefore, yeah, that symmetry properties also we have proved. So simply we have to prove the last property. But I think our last property will take more space. I think I'm going to cover the entire blackboard. So I'm going to remove this question. So make a screenshot of it, and after that I will start with very clean board. Okay, please make a screenshot of it. So let us start to prove the last property, that is triangle inequality, right? So how many elements are required for triangle inequality? 3 elements. I have already taken. X means xn, sequence xn, y means sequence yn, and z means sequence zn. Okay, so see, sequence xn means x1, x2, x3, x4, such terms we have, y1, y2, y3 and z1, z2, z3, like that. See, one thing I am going to write, okay, clearly, okay, clearly we can write mod xi minus zi, okay, mod xi minus zi is equal to mod xi minus yi plus yi minus zi. So you're getting my point. I'm simply adjusting one term, that means plus yi minus y. If you take separate mod, we will have less than or equal to mod xi minus yi plus mod yi minus z, and this is true for all I. This is true for all I. So if you take separate mod, value will get increase. Do you know one thing? If a less than or equal to b, and if you take their reciprocals, what will happen? 1 by a will be greater than or equal to 1 by b. So see, if I take a reciprocal of both sides, so we will have therefore 1 upon mod xi minus zi, inequality will get changed. 1 upon mod xi minus yi plus mod yi minus zi. Is it okay? If I take a reciprocal, inequality will change, and this is true for all I belongs to set of natural numbers. Now I'm going to add 1 on both sides. Okay, I'm going to add 1 on both sides. So therefore 1 plus 1 upon mod xi minus zi greater than or equal to 1 plus 1 upon mod xi minus yi plus mod yi minus zi. Okay, so now after that what will I do? I will cross multiply. Getting? I'm cross multiplying. Cross multiplying means 1 into this one. Getting? So if you cross multiply, so mod xi minus zi plus 1, that means simply I can write 1 plus mod xi minus zi. Okay, mod xi minus zi. You can also check in your notebook also. If you cross multiply, we will have the same thing. Greater than or equal to, I am going to do the same thing. I am going to cross multiply. So this denominator into 1, you will have same denominator plus 1. So I am writing in this way, 1 plus mod xi minus yi plus mod yi minus zi divided by mod xi minus yi plus mod yi minus zi. Again I am going to take reciprocal of both sides. Again inequality will get changed. Okay, so what will I have? Therefore mod xi minus zi. Here already we had changed, we had taken reciprocal. One more time I am taking reciprocal. That means now denominator becomes numerator and numerator becomes denominator. So now we will have less than or equal to mod xi minus yi plus mod yi minus zi divided by 1 plus mod xi minus yi plus mod yi minus zi. Obviously this is true for all I, okay, belongs to set of natural number. Here also I supposed to write. After that, okay, what I'm going to do, after that I will divide separately. If I divide separately, what can I write if I divide separately? So this is equal to mod xi minus yi divided by whole denominator, 1 plus mod xi minus yi plus mod yi minus zi plus now this term upon whole denominator, that means mod yi minus zi divided by 1 plus mod xi minus yi plus mod yi minus zi. You remember such technique we have already used for one example. If you go and watch the previous videos, you can easily get it. Okay, same technique I am using. See, if you reduce the denominator, okay, I will write here my next step. If you reduce the denominator, possibly value will get increased. So therefore, this is less than or equal to, I am removing this denominator, so value will get increased. So mod xi minus yi divided by 1 plus mod xi minus yi. And here also I will reduce the denominator. I will remove this term. Okay, this mod I will remove, so value will get increased. So this is mod yi minus zi divided by 1 plus mod yi minus zi. Okay, a very important step we have got now. So let us write it properly. Therefore what we have now, I will write it properly. We have in left hand side we have this term mod xi minus zi divided by 1 plus mod xi minus zi less than or equal to, and the summation of these two terms we have in right hand side, xi minus yi upon 1 plus mod xi minus yi plus mod yi minus zi divided by 1 plus mod yi minus zi. See, Still one term is missing. Can you tell me which term is missing? 2 raised to I. In definition, we have already I removed the definition, but in definition, we have 2 raised to I. So I'm going to multiply both sides, okay, left hand side and right hand side by 1 upon 2 raised to I. That means 1 upon 2 raised to I should be in denominator. So therefore, mod xi minus zi divided by 2 raised to I 1 plus mod xi minus zi. Here also I am going to multiply 1 upon 2 raised to I mod xi minus yi divided by 2 raised to I 1 plus mod xi minus yi plus, okay, for this term also I will do the same, mod yi minus zi divided by 2 raised to I 1 plus mod yi minus zi. See, and this is true for all I belongs to set of natural number. It is true for all I. So that means if you take a summation of both sides, it is true again. Okay, I'm going to write here, but I don't have a space. Make a screenshot of it. I will just remove this part only and I will take a summation there. Make a screenshot of it, please. Okay, so let us take summation of both sides. So here I will write summation I running from 1 to infinity, okay, mod xi minus zi divided by 2 raised to I 1 plus mod xi minus zi, okay, less than or equal to summation I running from 1 to infinity mod xi minus yi divided by 2 raised to I 1 plus mod xi minus yi, and here one more term is there, plus summation I running from 1 to infinity mod yi minus zi divided by 2 raised to I 1 plus mod yi minus zi. Okay, so yeah, this is a definition which is given to us right now. So this is a definition, therefore d of xz, this is d of xz less than or equal to this is d of xy, and last one is d of yz, and it is true for all x, y, z belongs to x. So that means our D satisfies last property also. It satisfies all properties. So that's why we can declare it is a metric on X. So let me write just one sentence. Therefore, D is metric on X. So in this way, we completed this example. Make a screenshot of it and after that we will stop. Thank you. Bye-bye.